And the final chapter is about quadratic models. Now, because the vertex of a parabola is the highest or lowest point on the graph, equations in this form are important for certain problems where we must find the maximum or minimum of some quantity. So remembering that when a is less than 0, the parabola opens down, the y-coordinate of the vertex gives us the maximum value of y. So here we are going to have an x value, and then that is going to be the maximum value. But when a is greater than 0, the parabola opens up, and the y-coordinate is going to give us the minimum value of y. The x-coordinate of the vertex tells you where that happens, so that is also going to be important. We may also be interested in the x-intercepts of a parabola. So we're looking at two things, either the vertex or the x-intercepts. Those are really the two most important things that we use parabolas for when we're modeling. So let's look at a few examples that utilize those. Here we have a ball that is projected directly upward with an initial height of 100 feet and initial velocity of 80 feet per second. Ooh, I thought they gave us the equation for this. So pause while I get you that equation. You will not be asked to do these without the equation provided. I just missed that on there. So that's my bad. Okay. Here's the equation that goes with that. Give the function that describes the height of the ball in terms of t. It is s of t is equal to negative 16t squared plus 80t plus 100. So just in case you're ever asked to do that, the general formula for that is the height of the object is given by negative 16t squared plus the initial velocity times time plus the initial height. So they gave us an initial height of 100. That's where that 100 came from. An initial velocity of 80, which is where that 80 came from. The negative 16t squared is because of the acceleration due to gravity. So just in case, now we know how to do that. So letter B, which is what I'm really more interested in. After how many seconds does the ball reach its maximum height, and what is the maximum height? So this equation is a parabola that opens down. So that equation is going to look like an upside down parabola. Every ordered pair on that parabola has an x value that's given by the letter t and a y value that's given by the letter s, which represents the height of the object, the ball in this case. So when they ask us for the maximum height, we are looking right here at the vertex. The vertex is going to give us a time and a maximum height. So all they really need you to do in letter B is to find the vertex. Well, good thing we know how to do that. To find the vertex, we are going to find the opposite of B over 2A, and then we are going to substitute that back in to the equation to get the y-coordinate. The x-coordinate will tell us the time. The y-coordinate will tell us the maximum height. So here we go. T, in this case, because it's in the T spot, will be the opposite of B, so negative 80 over 2 times A, so 2 times negative 16. So that is negative 80 over negative 32. That's not going to come out evenly. 80 divided by 32 is 2.5. So that is after 2.5. So after 2.5 seconds, the ball is at its maximum height And we're about to figure out what that is of blank. What is this measured in feet? Okay, so let's figure out how many feet that is by substituting 2.5 back into S. So S of 2.5 would be negative 16 times 2.5 squared plus 80 times 2.5 plus 100. Negative 16 times 2.5 squared is negative 100 plus 80 times 2.5 is 200 plus 100. Hey, remember when we sub those in, these two should be opposite signs and one should be twice as big, and that worked. So that is negative 100 plus 200 plus 100 makes 200, right? Negative 100 plus 200 plus 100, 200. So the maximum height would be 200 feet, and it happens after 2.5 seconds. Letter C. For what interval of time will the height of the ball be greater than 160 feet? So C. The height of the ball is this equation. So we want to know, when is the height of the ball greater than 160 feet? Well, we have solved these nonlinear inequalities in previous sections. What we wanted to do was replace the inequality symbol with an equal sign and solve that equation. So I need to get that over to this side. Negative 16t squared plus 80t minus 100, minus just regular 60 equals 0. Okay. All right. At that point, I would probably use the quadratic formula to figure out my values of t and set myself up with a test chart. And then I would test a value in each of those intervals. So I really don't want to take the time to solve that. So I'm just going to do that right quick on my calculator because I just need to have it done quickly. Oopsie doopsie. Next. Go back. Clear. Okay, I got this. Negative 16. 80. Probably could have just done it just as fast by solving it, but I also don't want to make a mistake. Oh, and they're like not nice numbers. So it's about 0.92 and about 4.1. So I would test values in here to see which ones come out true. How will I know? So I could like choose 0 here, and that's going to give me 100 is greater than 160, which is false. I could pick 2 here. So negative 16 times 4 plus 80 times 2 plus 100 gives me 196. 196 is greater than 160, so that is true. And then if I pick 10 here, that's like negative 1600 plus 800 plus 100 is greater than 160, which is false because that's like negative 600 and something. So that is false there. But guess what? We could also, like, once we have these two numbers, think about what's happening. If I have my ball that's going up and then back down, and this is my 160 feet, then these are the times it's at 160. So in between those two times would be when it's above 160. So it would be above 160 between t equals 0.92 and t equals 4.1 in interval notation between those two times. I'm not super worried about C. I don't think you'll see a lot of problems. Haha, get it, C. I don't think you'll see a lot of problems like that, but we do want to know after how many seconds will the ball hit the ground. That we are concerned about. So we're going to work that problem. Oh, gosh. I need a Post-it note. I don't have room. Maybe you guys will. After how many seconds will the ball hit the ground? This is a big one in parabolas. So the ball hits the ground when its height is 0. Its height is given by this equation. So all I need to do to figure out when the ball hits the ground is set this equation equal to 0. Now, usually there is a GCF you can take out to make this easier. I'm going to take out -4, so that's going to give me 4t squared minus 20t minus 25 equals 0. And then I could use either the quadratic formula or completing the square or factoring to figure out the values of t. Let's do quadratic formula. So I'll do opposite of b, so 20, plus or minus square root of b squared, 20 squared is 400, minus 4 times a, which was 4, times c, which was -25, over 2 times a, which was 4. So this is going to be 400, and then it becomes plus 4 times 4 times 25 is 400. So 800. 800 breaks down into 100 times, actually I could do 400 times 2 because 400 is 20 times 20, so that makes 20 square roots of 2. Okay, 20 square roots of 2. So t would be 20 plus or minus 20 square roots of 2 all over 8. Now, all three of those numbers can divide by 4. So that's going to be t equals 5 plus or minus 5 square roots of 2 all over 2. And most likely they're going to ask for decimal values. So I'm going to do 5 plus 5 square roots of 2. I did not do plus. 5 plus 5 square roots of 2 divided by 2. So 6.04 seconds. And 5 minus 5 square roots of 2 divided by 2 is -1.04 seconds. So those are the two values I got for t. So what makes sense about this is that I'm throwing a ball up in the air. So here I am, a person, throwing a ball up in the air, and it's coming back down. Well, here's the ground. The time that I release the ball is at t equals 0. So right here is t equals 0. And right here is t equals 6.04. So where's the -1.04 coming from? Well, if I drew the rest of this parabola, it would be right here. So it's happening before I throw the ball. So what we're going to do is disregard that negative value for t, and we would say it hits the ground after 6.04 seconds. Okay, good times. Now let's look at some business or profit examples. These are really important. Here I have a food truck. Daily costs for a food truck business that sells pizza by the slice are approximated by this quadratic function, where C of X is the cost in dollars to sell X slices of pizza. What would this graph look like? Well, it's a parabola. How do I know? Because it's an x squared graph. Well, does the parabola open up or does the parabola open down? Since the coefficient out in front is positive, this parabola opens up. Every ordered pair on this parabola has an x coordinate that is the number of slices of pizza. So this is going to be pizza slices. The y coordinate is going to be the cost in dollars. So if I wanted to find the number of slices that should be sold to minimize the cost, guess where that's going to happen? Right here. Right here is going to be the minimum cost, is going to be the y value. The x value is going to be how many pieces of pizza I should sell. What is that point called? It's called the vertex. So what is this asking me to find? The vertex. How do I find the vertex? I find that by doing the opposite of b over 2a and then subbing it in. So here is the vertex. It is the opposite of b, so positive 0.64 over 2 times a, which is 0.00128. 2 times 0.00128 is that number, so 0.64 over 0.00256, which is 250. How do I get the y coordinate? By substituting that back in for x. So c of 250 would be 0.00128 times 250 squared minus 0.64 times 250 plus 200. So I take 250 squared times 0.00128. That gives me 80. 0.64 times 250 gives me negative 160, and then plus 200. Look at that. Those two numbers are opposite signs. One is twice as big. So I know I'm right. 80 minus 160 plus 200 is 120. So the coordinates of the vertex are 250, 120. Remember that the x coordinate told me the number of pizza slices and the y coordinate told me the cost. So the question was, find the number of slices of pizza that should be sold in order to minimize cost. So now I know you should sell 250 slices of pizza to minimize cost at that cost would be $120. All right, next example. Fuzzy Pets is a company that makes electronic pets. The profits of the store are given by P of x equals negative x squared plus 980x minus 3,000. Oh my gosh, what shape is that graph? It's an x squared, so it's a parabola, and the number in front is negative, so it is an upside down parabola. Let's see what the ordered pairs represent. X is the number of pets sold each week. So, number of pets sold each week. That's our x coordinate. What's our y coordinate? The profits of the store are given by P of x. So it is profits. And they want us to find the maximum profit. Where on earth will we find the maximum profit? Ooh, I know. It's at the vertex. So what are they asking us to do in this problem? Find the vertex. Anytime you see a parabola equation and somebody asks you to find the maximum or minimum or the highest or lowest or least or most, you're going to be finding the vertex. So we're looking for x equals opposite b over 2a, which is opposite of b, negative 980 over 2 times a. A was negative 1. So that is going to be 490. So we should be making 490 pets each week, or selling 490 pets each week. To figure out our profit, we are going to replace x with 490 in our equation. So we have negative 490 squared plus 980 times 490 minus 3,000. Negative 490 squared. Oh, that's a big number. Negative 240,100. 980 times 490 is plus 480,200. Opposite signs, twice as big, minus 3,000. So I need this number plus this number minus 3,000 is 237,100. So this is our maximum profit. So that is going to be $237,100. And we should be selling 490 pets each week.